Am I audible to you all? Please write in the chat box. Then I'm going to start this session. Okay, 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 okay. So I welcome you all to this tutorial session on the topic of power system engineering. This tutorial session will be taken by me, Mohd Owais Khan, the Prime Minister Research Fellow at the Department of Electrical Engineering, Aligarh Muslim University. So far, I think you have gone through your lectures, okay, and you have gone through the week second lecture where you have learned about the insulated cables and the how we can calculate the capacitance and the intersheath grading of cables. So basically, in the previous lecture, what I have talked about regarding, the insulation. So, what type of insulation are we going to require in a bit? Okay. So basically, the insulation helps in helps in by doing the following work. Okay. Actually, okay, not this. So actually, we will talk about what type of insulation material we require. Means requirement of insulating material. See what type of material we should use so it provide a better insulation in the cables. So the requirement for that insulating material is that it should have a high insulation strength, or we should say resistance. Okay. Then the dielectric strength, then the dielectric strength should be high. Third is the mechanical properties. The mechanical properties. It should have tenacity and the elasticity. Okay. Then fourth one, chemical effect. Chemical effect on the material should be less. So the chemical effect on the insulating material should be minimal or not effective. Okay. So these are all the requirement of any these are all the requirement of insulating material. Another one is that the fifth one, it should be non-hydro non-hygroscopic. Okay. It means that it should not capture the moisture because the dielectric strength is heavily affected by the moisture. because if the moisture contained in any dielectric material or a material which is much more affected by the moisture, its dielectric strength will become less effective. Okay, so basically this is all about that thing. Okay, so now next is, what are these type of material? So first one is a vulcanized rubber. It is also used as a dielectric, sorry, insulating material. What happens here is that in the natural form, the rubber, in the natural form, rubber, let me change its color. In the rubber absorbs moisture. Okay, then what happen here is that it gets readily oxidized, and when it absorbs the moisture, it loses its dielectric properties. But what happen here is that when it is mixed with sulfur with a carefully chosen ingredient, what will happen here is that it's become non-hygroscopic. Non-hygroscopic means it does not capture or absorb the moisture, and thereby increasing the increasing the increasing the insulation properties. Okay, then we have another type of insulating material which is PVC. It is known as polyvinyl chloride. Okay, it is a polymer. It is a polymer which is formed by acetylene, and other methods of polymerization. Okay. Then there is another insulating material which is impregnated paper. Must have heard this. Okay. So basically, these all are what they do here. They are all the properties of the insulating material. Okay. So now we will, move on towards the how do we can calculate the intensity, or what type of numericals we can do. So basically what we will do here. Okay, now, so let me go towards the another topic here, which is electrostatic electrostatic stress in a single core cable. Okay, how do we calculate? I think derivation is not possible in a 2 year hour lecture. So what will I will do here? I will give you the formula, then we will solve some questions on that. Okay. So basically, in this, what happens here is that, let's say there is a conductor whose radius is r. Let r be the radius of the conductor. I will explain in a brief, then we will solve some question on that. Okay, it will help you the understanding of the topic very much. Okay, so let R be the radius of a conductor. Let this is R. Okay, and capital R is the inner radius of sheath, and this is the permittivity of dielectric. So basically here this is conductor and this is dielectric. Okay, and and one more thing is here, just like this. So basically this is R, which is sheath, and its inner radius is capital R. Okay, so and lambda is the charge per unit length. So if we calculate the V, the potential of a conductor with respect to sheath, potential with respect to conductor of sheath, then what it will be? V is equal to is integration of E dx from capital R to small r, from here to here. Okay, so if we calculate, I'm going to write the right direct equation. So it will come out to be lambda upon 2 pi epsilon log capital R by small r. So this is the voltage potential, which is lambda by 2 pi epsilon log capital R by small r. Okay, and we know that here we can say that G is equal to lambda upon 2 pi epsilon, lambda by 2 pi epsilon. So what is G? G is known as the gradient at a distance. Actually, it is a gradient for the time being now. Okay. So if we put this thing here, so V will come out to be G log capital R by small r. Okay. At a distance x from the center. Okay. So it will be G into X is if we if I rearrange this, Gx is equal to lambda by 2 pi epsilon naught. So it will be Gx. Now if we rearrange this for G, अगर हम इसको G के लिए rearrange करते हैं, it will come out to be V upon X log capital R by small r. So from here we can see that the gradient will be maximum when x is minimum. X is minimum. So x is minimum at x is equal to small r. It is the minimum value. So we can say that G max will be equal to what? V upon small r capi log r by r. And G minimum will be where? When x is equal to maximum. A maximum value is R because a capital R is a larger value in comparison to a smaller r. Okay, so these are the equations like here. And if we, plot this diagram of G, if we plot this G with R by capital R, it will come out, the graph will vary like this. Okay, graph will vary like this. And this point is comes out to be 0.365. Okay, so this is all about the electrostatic stress, which is the gradient at a distance x. Now we will solve some question for this, like for example, like question number 1. Okay, determine determine the overall diameter of single core cable metal sheathed for a working voltage of 85 kV. Okay, the dielectric strength dielectric strength of the insulating material of the insulating material is 65 kilovolt per centimeter. Okay, so we have to calculate the overall diameter. Okay, so here one of the most important thing is this: we have to calculate the actually one thing is economic overall diameter of that. So for an economic operations, for the economic operation, I will solve it for you. For the economic operations, the for the economic operations, sorry, operations for economic size. For economic size of cable, the outer dia of the conductor, the outer dia, the ratio of outer dia of the conductor to the conductor dia must be E. ठीक है? So basically, what we are going to see here, capi let's say R1 is the outer dia and R is this is equal to E. So using the equation of voltage, what is voltage equation? This one, where we know the stress. Okay, so V is equal to R G max log R1 by R. Okay, so here R G max log R1 by E, R is E for the economic dia. Okay, it should be equal to E. So basically, it will come out to be R G max. And just a second, just a second. Okay, I think I'm visible. Okay, this is R max, R into G max. So basically, it will be equal to this. But the voltage here is working voltage is 85, which is equal to the dielectric strength of insulating material is which is G max, which is 65 R. And if we solve it for R, it will come out 85 upon 65, which is something around 1.3 centimeter. Okay, and the dia of the conductor will be 2 times of R, which is 2.6 centimeter. Okay, and the dia of the sheath, it will be equal to 2.6 times E, because we know R1 by R is equal to E, and we just calculated R. So if we multiply it by E, it will give us the value of 7.07 centimeter. Okay, so what it will do here, it is to calculate the economic size. Okay, for economic size, we will we will put the diameter of the sheath this much and the diameter of the conductor this much. Okay, now moving on towards the next topic. Here is the grading of the cable. Grading of the cables. So what happens here is that we have you have already seen here is that there are maximum gradients and the minimum gradients. A maximum gradients comes when x is equal to small r, and the minimum gradient will be when x is equal to r. But the problem is that here is that we should the distribution of electric material by why we do the grading of the cables, because the difference between G max minus G min can be reduced. Then basically reduction of this difference between the G max and minus G min can be done by the help of the grading of the cables. Okay, so what is the advantage of the grading of the cable is that a cable of same cable of the same size can be operated can be operated at higher voltages, or it will also lead to a smaller size of cables can be used for a same can be used for the same operating voltage. Okay, now there are two methods to grade the cables. There are two methods to grading of the cable. First is the capacitance based method. Capacitance based method. Second is the intersheath intersheath based method. Okay, now what happens in the capacitance based method? Generally, we use different types of material where more than one dielectric material is used. But in intersheath method, what happened here is that same dielectric is used, but the potential at at certain radii are held to a certain value by interposing the interposing metal sheath. So here, how we can acquire the grading? Here, same dielectric same dielectric material is used, but but the potential the potential the potential at at certain radii radii is maintained by interposing interposing metal sheets, okay, which are thin in. Okay. So first of all, we will go on towards the capacitance grading. So capacitance grading. Okay, I will briefly, introduce that. Okay, briefly explain how we going to calculate the capacitance grading, and then we will solve some questions on that. Okay, so now what happens here in the capacitance grading? Let lambda is we know the charge per unit length. Okay, and if we have one single dielectric, and we so the gradient at any point x will be g is equal to lambda upon 2 pi epsilon x, where epsilon is the permittivity of the dielectric of the material. And then if we now what happens here is that if we use the dielectric of different permittivities, if we use dielectric of different permittivity, then the epsilon will be k by x. Okay, then what happens here is that g is equal to lambda upon 2 pi epsilon k by x into x, which is equal to lambda upon 2 pi k. Now, what, how we can explain this? If we use a dielectric of infinite numbers of materials which have a permittivity, then whole region like there are infinite number of materials, but they have and they are distributed over a length x, then it will be k by x. So this is the thing with that. Now, we will move towards the another thing here. Now we will derive the formula for the voltage by using this concept, okay, which I just told. Let there be a cable. Let there be a cable of single core but three materials three materials like this, like this. Here it is R, we already know. Another, it is R1, which permittivity of epsilon 1. Then we have another here R2 with permittivity of epsilon 2, then R3, and this is let's say this is capital R. Okay, so the operating voltage of the cable here V is equal to, I will write it down directly the formula instead of going towards the derivation. G max R log R1 by R. For this it will be the outer, so R1 by R plus R1 log R2 by R1. For next, here it will be R1 log R2 by R1 plus R2 for this one. This will outside radius will be R, capital R, and inside radius will be R2. Okay, so this is how we calculate the total operating voltage at any point of time. Okay, now next is for the intersheath. Next is for the intersheath grading. I will write it down the direct formula. We will solve some questions on this basically. Okay, because derivation is very much lengthy and we have limited time. So for an intersheath, the voltage of the cable with this intersheath, let's say there is, let's say there is intersheath grading in a cable. Okay, in intersheath, what is there? A same dielectric is used. So basically, epsilon will be the permittivity and it will remain same. Because in an intersheath we maintain the temperature, we maintain the voltage at the prescribed value by using the metallic intersheath posings. Okay, but in the dielectric we change material, we use for some distance, for some radius different material, for another distance, for another radius, for the another different material. So basically this is R. This one will be R1 but permittivity will be epsilon. This is R2 permittivity epsilon, and this is capital R, the permittivity will be the same epsilon. So basically how we are going to maintain this, it is by using an auxiliary transformer. Okay, so there will be transformer, an auxiliary transformer will be used. First it will be connected here. Okay, then it will be connected in here, and then it will be connected actually one, it will be connected here, then here. So basically we can maintain the voltages. Let's say this is V1, this is V2, this is V3, this is V4, because the number depending upon the number of trans winding, it will give the voltage, and we can fix the voltages just like I have said in the intersheath grading. So basically, but the thing is that the thickness of the material are such that R1 upon R is equal to R2 1 by R plus R by R2 is equal to alpha. Okay. Now what happens here is that the distress distribution is supposed to be different from one The objective now here is to calculate, is show that the gradient with intersheath will be smaller than the gradient without intersheath for the overall radius. Now the thing is that a homogeneous material is being used, and the maximum value of stress it at various intersheath will remain the same. So basically, we divide the thickness in such a ratio that R1 upon R is equal to R2 upon R1 is equal to capital R upon R2 is equal to alpha. So I'm going to write the final equation here. The voltage of the cable with this intersheath arrangement is given by V is equal to G max R log R1 by R plus R1 log R2 by R1 plus log R2 log capital R by R2. It is the same formula. Like for this R into log R1 by R. For the second R1 plus log R2 by capital R1. Then for R2 here log R2 by capital R by R2. But the thing here is that V is equal to G max log alpha multiplied by R1 plus R2 plus R. Why? Because we know that this value, these all three values are same because this is equal to alpha. So remaining will be inside that. So what it will give? It will give the voltage of cable with the intersheath like this. Okay. Okay. I hope you have understood this question regarding this. Okay. Now we will solve. I think before going on in details, we should solve some questions, and then it will help in the understanding of the problem. So let I will uh, give you a question. Question number two. Okay, what is this? 66 kV concentric cable with two intersheath with two intersheath. Okay, with two intersheath has a core diameter of 1.8 centimeter. Okay, you have to solve this question. Dielectric material 3.5 centimeter thick constitutes three zones. Okay, तो यहाँ पे क्या है, तीन जोन बना रहा है एक डाइलेक्ट्रिक मटेरियल. Now determine the maximum stress. We have to calculate the maximum stress, which is G, in each layer. If 20 kV is maintained across each of the inner two, ठीक है. So basically, इनर टू शीट के अक्रॉस क्या है हमारा वोल्टेज, it is maintained 20 kV. So I will draw a diagram, then you have to solve the question. Options तो नहीं दूंगा क्योंकि इसमें options वैल्यू निकाल के you should write in the chat box. So first is this, then this one is here, okay, then another layer is here, one, two, three, okay, one, two, three, then this is the conductor, okay. I think the diagram is quite visible to all of you. Small r is zero point 0.9, okay. The thickness is 3.5, okay, 3.5, तीन zone है. This is okay, and these two are intersheets, this one and this one. Now they have the voltage. So basically, how the voltage here is this. First here like this, okay, and V2 is this, and V1, and V1 here. I think they have given the wrong thing. This is V1, this is V, and this is V2, and they are connected to an auxiliary transformer. Okay, so basically, this is the diagrams. Now these two are intersheet. I will wait for a minute. You can write the answer in the chat box. The stresses निकालने हैं हमको where G1, G2 or G3 max at these surfaces 1, 2, okay, and here G1 is here, G2 is here, and G3 is here. Okay, तो हमको क्या निकालने हैं, G1 max, G2 max and G3 max. Okay, this is the first intersheet, this is the second intersheet, this is the surface of the conductor. Okay, you can solve it. If you can solve this question, it will clear your doubt very easily. If not, then I will solve it in a bit. If anyone have got any value like G1, you have got G2, G3, any value, you can write in the chat box. Okay. Okay. Now let me solve it for you. Now what happens here is that the overall radius of the cable, first of all, we have to find out overall radius of the cable. What it will be? It will be equal to zero point 0.9 plus zero point 0.9 means intersheath has a core diameter of 1.8. So radius will be divided by 2.9. Then 3 into 0.35. Why? Because 3.5 is there. Okay? 3.5 mm actually. This is mm. You must change it. That's why it will come. Okay, so three intersheets are there. Like this is 0.35, this is 0.35, okay, and this is 0.35. Then we have a intersheet. Okay, so basically the overall diameter radius of the cable will how much? Now 1.95 centimeter. Okay, now let's assume G1 max is the maximum stress at the surface of conductor. Okay, and G2 max maximum stress at first intersheet. Then G3 max is the maximum stress at second intersheet. Okay, so basically V1 minus V2, V1 minus V2 is given 20 because it is given the difference in the voltage between the sheets are maintained at 20 kV. So basically 20 will be V1 minus V2, which is equal to G max, actually it will be G2 max, G2 max R1 log R2 by R1. Okay, so it is first equation. V1 minus V2 is 20 and G2 max here R1 is, we have to calculate. If we G2 R1, G2 max is this, and R1 is, what is R1 here? It is the first intersheath radius. So it will be 0.35 log R2. R2 will be 0.75 divided by 0.35. Okay. So if we solve it, it will come out to be 0.3085 G2 max, which is equal to 20. Equation 1. Then we have V minus V1. V minus V1. Here it will be G1 max R log R1 by R because it will calculate at the conductor surface, and its value will be comes out to be if you put all these value 0.2956 G1 max. Okay, then V2, it is at the second intersheath, the maximum stress. So at the second intersheath it will be G3 max R2 because at the second intersheath the radius of will be R2 and R3 divided by R2. So if we solve it, it will come out to be 0.3165 G3 max. So basically what we have got here is this for G2 max. G2 max. Just a second. Let me write it down here. 20 is equal to 0.2956 G1 max. So if we calculate the G1 max here, it will come out to be 20 divided by 0.2956. It will be equal to 67.6 kV per centimeter. Similarly, 20 is equal to 0.3085 G2 max. It will come out to be how much? it will give G2 max is equal to 20 divided by 0.3085. So G2 will be equal to 64.83 kV per centimeter. Then we have G3, which is direct. We can calculate directly in there. It will be equal to uh, G3 will be equal to how much? Actually, for G3, we have to calculate V2 divided by 0.3165. But we just calculated how much we have to calculate this V2 first. So for calculation of the V2, we have to do here like one thing. So for V2, what it will be here, we will use equation V1 minus V2 is equal to. For this, I think we are going to use one thing here. Just a second. Just a second. Okay, yes. So basically, V2 will be equal to 66 minus 40. Okay, just a second. V1 minus V2 is equal to how much? It is 20, which is equal to 0.3085 G2 max. Okay, and just a second, I will solve it for you. And if we calculate, we have calculated the G2 max. Okay, then okay. So V2 will be equal to 66 minus, I think we don't need that. V2 is equal to 66 minus, I think, what it will be, 20 plus 20. Just a second, I'll solve it for you. Just because we have been maintaining the three layers at the 20 kV. Okay. So basically V minus V1 we calculate G1 max, then also V1 minus V2 we calculate this. So basically V2 will be 66 minus 40, which is 26 kV, and from here we will calculate 0.3165 G2. From here we can calculate, sorry, G3. G3 max, it will be 82 kV per centimeter. Okay. I will when I will provide the notes, I will explain this in the notes. Okay. For the time being, you just leave this thing here. Okay. I hope you get an idea how we are going to calculate this whole the thing. So basically, in this question, what has been given here, a 66 concentric cable with a 2 inch sheath has a diameter 1.8 centimeter is given, and that dielectric strength has been divided into three zones, and each zone has a thickness of 0.375 centimeter. Okay, so now we will solve another question. I will write the explanation here. Okay, do not worry how we are going to calculate it when I will provide the notes. Just now I'm not getting it. Okay, so next question here is question number third. A conductor of 1 centimeter dia passes centrally through a porcelain cylinder, okay, of internal dia 2 centimeter and external dia of 7 centimeter. This cylinder is surrounded by this cylinder is surrounded by fitting metal sheath. Okay, the permittivity of the permittivity of porcelain is 5 and the peak voltage gradient in air must not exceed 34 kV per centimeter. Calculate, sorry, the maximum safe working voltage is. First, 10 to 11 kV RMS. B, 11 to 12 kV RMS. C, 20 to 22 kV RMS. D, 22 to 25 kV RMS. So write in the chat box the correct answer. What the question says here, a conductor of 1 centimeter dia passes through a porcelain cylinder of internal dia which has a dia of 2 centimeter and external dia of 7 centimeter. The cylinder is surrounded by a tightly fitting metal sheath and the permittivity of the porcelain is 5 and the peak voltage gradient in the air must not exceed 34 kV per centimeter. Okay, the maximum safe working voltage is, you have to give me the correct answer. Okay, it's a very simple question. You use the formula of maximum stress, G is equal to Q upon 2 pi epsilon naught R. So, and calculate for the various surface. For let's say G1 calculated is R, for G2 calculated R1. Based on that, you can calculate the voltage also. Okay, because we have to calculate the total maximum safe working voltage. Then we have to consider both G1 plus G2. Both stresses we have to calculate. Okay, so I will wait for your answer in the chat box. Okay, please write in the chat box. I'm waiting for your answers. Answer is B. Okay, let me see others. Anyone else who can solve that? Those who have any query can write in the chat box. I think someone has raised a hand, but I'm not getting how to allow that. Okay. If you have anything like that, you can raise, you can write any query in the chat box. Okay. So basically, single person has given the answer. It is correct. Okay. So the configuration here is that this is the conductor. Okay. And after that, we have this much, and this is okay. Just a second.
How will you access the chat box?
If you have any query, you can write in the chat box, okay? Instead of using your mic. Okay. Okay, now this is R is equal to zero point 0.5. Then another, this is R1, and this is capital R. Now in the question it is given the capital R is 7 divided by 2, 3.5 centimeter. And okay, and small r is zero point 0.5, and R1 is internal dia, which is 2, then it R come out to be 1 cent. Okay. Let lambda be the charge per unit length, okay, of the conductor. Then G1 max at the conductor surface Q divided by 2 pi epsilon naught R, okay, and then G2 max at the second surface, it will be Q divided by 2 pi epsilon naught 2 pi epsilon R small r1, okay, because it is a porcelain which has a permittivity of 5. Okay, give the sag formula. I think you should go to the last lecture. I have talked about the sag formula and I have solved, I think various questions on that. Okay. basically how we can calculate the sag here. Okay, so I think you should go through the last lecture, and we I have talked about how we can calculate the sag and where. Okay, two three questions also. So you should go toward the last lecture, video lecture. Hope you have the link with you. Okay, so basically G2 max is equal to, just a second, because the material has changed, the relative permittivity is 2 pi epsilon naught R1. Okay, now here if we multiply G2 max by epsilon R R1, it comes out to be Q 2 pi epsilon naught. Okay, and this Q upon epsilon naught here will be equal to G1 max into R, Q upon 2 pi epsilon naught. Let's say this is 1, this is 2. So these both are same. So R into G1 max is equal to epsilon R R1 G2 max. So from if we rearrange this, G2 max will comes out to be R into G1 max divided by epsilon R. By the way, now how to one will get from, by the way, now how to get value from where? T1 value? Like what? It's T1 value.
Yes.
G2 is equal to R G1 max upon epsilon R1. Okay. So basically, what is R? We just calculated. It is zero point 0.5, and G1 is the dielectric strength, which is given maximum allowed 34. Epsilon R is 5, then R1 is 1. So it will come out to be 3.4 kV per centimeter. But we have to calculate the maximum safe working voltage. So for this, the maximum safe working voltage is equal to V R G1 max log R1. Which T1 value are you talking about? Either it is R1, there are R1 values in this question, and I don't think I have used T here anymore in this previous question. Write the question number, then I will answer that. R1, okay, now you are right. Actually, R1, it is given here now. I think if you have joined initially, here what we have, there is a, this is the conductor, okay. Then what here is this? It is saying a conductor of 1 centimeter dia passes through a porcelain cylinder. So basically we write conductor radius as R. Then it passes through a porcelain cylinder of internal dia 2 centimeter and external dia 7 centimeter. Then this cylinder is surrounded by a metal sheath. तो बेसिकली मैं अगर इसको अगर सही से बनाऊं तो एक मेटल शीट और है इधर, ठीक है। तो ये तो कंडक्टर है, दिस इज द कंडक्टर। ये एक पोर्सिलीन के थ्रू मूव कर रहा है, जिसका इंटरनल डायमीटर R1 है और एक्सटर्नल डायमीटर, सॉरी रेडियस, सॉरी R है, ठीक है। अब हमें क्या करना है, वी हैव टू कैलकुलेट द मैक्सिमम वर्किंग वोल्टेज। So what we have said here, its internal radius is R1. R1 is porcelain. Okay, let me write it down. Porcelain cylinder internal radius. Okay, then either we can use it capital R or small r. That's just nomenclature part. But because we have you derived the formula on the basis of capital R, because the larger value we represent by capital R, we are going on the similar lines. So this much is the porcelain porcelain external radius. Okay. Then after that, this whole system is surrounded by a metal sheet. For this system, we have to calculate the maximum safe voltage, working voltage. But there is a condition given in the question is that the peak voltage gradient in air must not exceed 34 kV per centimeter. So basically, we are doing just like that. Okay. So basically, log R1 by R plus, where am I? R1 G2 log capital R by R1. Or this equation is actually you have gone through the lectures or your books, because I cannot derive this equation in a 2 hour, because we can if I derive these equation, then we will not able to solve the question. And solving question is very much important, because this value formula you can see from the book, but question solving is a very different thing. So that's why I'm going to solve the questions for you. So basically, V is equal to R. What is R? Zero point 0.5. G1 max, it is giving 34. Then log R1 upon R, which is 0.5, plus R, R1 is 1. G2 max, we just calculate 3.4 into log. Then capital R, it is capital R is the external radius of the porcelain cylinder. So basically, it will be 3.5 divided by R. These all values are given in the question. So if we solve it for this part, I think it will come out to be zero point 0.5 into 3.4. It will be around 1.7. And if we log it, it will uh, write the value of this part. Write in the chat box all, solve this part and give give me the value. And then for this part, write the value here in the chat box. Let me see how much you are getting it. Calculate the value zero point 0.5 into 34 into log 1 by zero point 0.5 using the calculator. I am waiting for the answer. No one is going to calculate. इतना टाइम लगेगा कैलकुलेट करने में? This is 11.78 plus 4.3. Okay, and this is the peak. So it will be 16.04 kV peak. And in the question we have to calculate the RMS, then VRMS is equal to 11.34 kV RMS. So based on that, the answer will be, it will come out to be 11 to 12. There must be some calculating error. No, we have to, this is the peak value. We have to, calculate by the RMS value. And for RMS, I think it will come out to be, Yes. For RMS divided by the root 2. Then you can get the RMS value. Okay. Now we will move on towards the another topic, which is the insulation resistance. Okay. Insulation resistance. So what happens here is that usually when the current flows through the cable, the current which is not useful flows radially from the conductor to the sheet through a dielectric material. And we know that the insulation, got it? Okay, okay, nice. Insulation, actually, before I move on towards this, I have to clarify one thing. Okay. In this numerical, how we are going to calculate V2? Okay, because I have told you about it, I will write its explanation later on, but let me write it down here. Okay, what happens here is that V1 minus V2 is 20. Okay, but we have to calculate the V2, which is okay. So what happens here is that in the diagram, you can see that, just a second. In the question, it been said that it is a 66 kV concentric cable with a two intersheath. So basically, what happens here is that कि यहाँ पे जो टोटल वोल्टेज है इसका वो कितना है 66। अब उसमें दो शीट पे यहाँ पे और यहाँ पे हमने ये बताया कि वोल्टेजेस हमारे कितने हैं इन दोनों के बीच में 20, देन इन दोनों के बीच में 20। तो हमें इस टाइम इधर पे हमें वो चाहिए वोल्टेज। ओके, तो अगर हमें दो बाकी के बीच में पता है एंड वी नो द टोटल वोल्टेज, so if we 66 minus 20 then again minus 20, so it will come out to be 66 minus 40, so it will be equal to 26। तो इस तरीके से हमें 26 केवी आया यहाँ पे फॉर द कैलकुलेशन ऑफ G3, बिकॉज इंटरनल टू लेयर्स पे हमारा जो वोल्टेजेस था वो कैप्ट कितने पे रखा हुआ था 20 पे रखा हुआ था। तो हमें थर्ड सरफेस पे हमें वोल्टेज चाहिए था विच इज V2। For the calculation of that third surface voltage, we subtract the total voltage from the first layer voltage, then again the second layer voltage. And by subtracting this, we calculate the voltage at the third layer. At that third layer, we calculated the G3 max. So this is the proper explanation because at that time I was not able to give that. So now for V2, we calculated like this, and it is quite obvious 26 is equal to 0.3165 G3, and we divided by that we calculated the G3. So please keep this thing in the mind. Okay, now we move on toward the next, the insulation resistance of the cable. What is the how we calculate insulation resistance of the cable is given by the formula R is equal to rho upon 2 pi L log capital R by small r. Okay, capital R by small r. This is the small r and this is the capital R. Okay, weightage of this topic, it's quite weightage तो काफी ज़्यादा है। I think it has a there are at least 10 to 12 number questions come from this easily. Okay, so from here we calculate the insulation resistance. So basically now what I will solve some questions. You have to give the answer. The question number 5, the insulation resistance of a cable is related as first R is directly proportional to L, R is directly proportional to 1 by L, B R is directly proportional to L square, and D R is directly proportional to 1 by L square. So give me the answer in the chat box. Give me that answer in the chat box. The insulation resistance of a cable is related as. It is quite e- explanatory. R is what is R? Rho upon 2 pi L log capital R by R. So R is directly related to 1 by L. So basically, the B is the correct answer. Okay. Now, next question here is this. Question number 6. As the thickness of insulation of cable increases, its resistance, which is insulation, first increases, B decreases, C remains same, D none of the above. So give me the answer. As the thickness of an insulation of cable increases, its insulation resistance, no, it's increases. Okay, insulation resistance increases. Yes, yes. So it is A. Now question number 7. The capacitance of a cable and the relative permittivity. Permittivity is are related as A. C is directly proportional to 1 by epsilon r. B. C is directly proportional to R. C is directly proportional to sigma R square, and D, C is directly proportional to 1 minus sigma R square. Give me the correct answer in the chat box. Yes, yes, yes. The capacitance of single cable is given by C is equal to 2 pi epsilon log capital R by R. So it is C is directly proportional to epsilon R. So basically B is the correct answer. Okay. Now question number 10. For the same potential for the same safe potential for the same potential, the size of a graded cable is, first option is less than non-graded cable, less than non-graded cable, B, more than non-graded cable, then C, same as non-graded cable, D, none of the above. So write in the answer the correct option. Anyone else? Yes. Yes. The thing is that why we do graded of the cable. The mean you know the main aim of that. Yes, 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 exactly. The main aim of the grading of the cable is to reduce the stress. Okay, and also what happened here is that when we reduce the stresses on the cable, the size gets lower. Okay, size gets shrinked. So that's why our non-graded cable is much more of a size than a graded cable. So that's why a graded cable has a lesser size than a non-graded cable for a same value of voltage. So question number, okay, 11. Which of the following is correct? For a single core cable of diameter D and internal sheath diameter D. पहला ऑप्शन है G max by G min is equal to D by D B G max by G min D square by D square. B is G max by G min is capital D by D. Then A B C D. Fourth, none of the above. So give me the correct answer. A B C D. Only singly. I have changed that. Yes. So, okay. Yes. Just a second. Yes. What is it? The question says which of the following is correct? We know that G max G is directly proportional to 1 by R. So G max will be at the smaller d, then G mean will be capital. If we calculate this, so C will the correct answer. Okay, and just a second. I have to solve you some questions also. Okay, and okay. 15 C option. Okay. Now next question here is question number 11, 12. The most economical conductor dia D is equal to 2.718 by D. For the same question, it is a continuation of that question. A option, B is D by capital D by 2.718, and C is D is equal to 2.718 D. C none of the above. So give me the answer. Yes. So the answer to this is C. The most economical D is equal to 1 by R. No, 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 no. Oh, 2.718. No, no. The answer is this. Just a second. It's this. D is equal to D by 2.718. This is the correct. Okay. Now another question which is very much important. It will give you an idea. In capacitance grading, the cable of higher the cable of higher electric permittivity. Sorry, what I'm saying. The cable of higher permittivity is kept first near the core, in the middle, C farther, D none of the above. Okay. Yes. 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 अब क्या होता है जिन कैपेसिटेंस ग्रेडिंग जो केबल होती है विच इज हायर परमिटिविटी तो उस पे स्ट्रेसेस क्या होंगे इट विल हैव अ लोअर स्ट्रेस बिकॉज G is directly proportional to 1 by epsilon. So that's why that is put near the core. Okay. Now question number 14. In the capacitance grading, we use single dielectric, B multiple dielectric, C none of the above. Yes. कैपेसिटेंस ग्रेडिंग में क्या करते हैं हम वी यूज डिफरेंट टाइप्स ऑफ डाइलेक्ट्रिक टू इंक्रीज टू ग्रेड द केबल बट इन इंटरशीथ but in intersheath we use only single dielectric. Okay, only single dielectric, but in capacitance we use multiple. So correct answer is the this one. Okay, just a second. Now we will move on towards the another question. Let me give you another question so it will be better for you to understand. So the question here is uh, you have to solve it and give me the answer. It's a simple question. The a single core gives the answer for question number 13. Actually, the thing is that I don't have the uh, questions from the NPTL. Okay, so there are some questions which I have because my access was revoked. So basically, I didn't get the questions. Some questions which I have done, I solved you. And if there are any specific question, we you can come in the next week and I will solve it. Okay, those assignment problem questions. Okay. So basically, I don't have right now with me the assignment problems, but on the similar lines, I have solved various questions for the your understandings of the subject. Okay, exact question I don't have, so that's why I'm not able to give you the answer. I can give you the answer, but the problem is I don't have the questions with me because I'm not able to download that from the NPTL because they provide the question, but somehow there is some problem with the download. That's why exact those questions I have not solved with you, but on a similar line, the same topics, I have solved the various questions. Okay, so if you have any exact question, you can write it here, and I will solve it in the next week if I have got those questions. Okay, a single core has a conductor dia in session 13. Which session 13? The dia of in a single core has a diameter of 1 centimeter of 1 centimeter. Question 13. Yes, yes, the problem is that I don't have the questions, the assignment question at the NPTL because there was some problem at the portal. I was not able to download. Okay, so that's why I have not solved the exact those questions. But on the similar lines, I have made up my own questions and solved it for you so that you can understand. If the specific and if you have any specific question that you want to answer me, you can give me the question number. In the next week, you can join there and I will solve it for you. If the specific resistance of insulation is 5 into 10 raised to the power 14 ohm, which question? Okay, this is the near the core. For this one, you are asking for. Is it okay? Okay, okay. You are asking this question number. Okay. Reason, okay, okay. Reason I have told you. In the capacitance grading, the higher permittivity is kept near the core. Reason is this because the cable of a higher permittivity will have a lower stress because it's G is directly proportional to 1 by epsilon. Epsilon, epsilon r. If any cable has a higher permittivity, it has a lower stress. So that's why it is kept near the core. Okay? I thought you were asking something other than that. Is it okay for you? Let me give you one more question. The insulation resistance of 2 kilometer cable will be. Give me the answer. A234 B 1117 B C 468 and D 250. Now solve this and give me the answer. So basically, let me solve it for you. Here, the length of the cable is given. L is equal to 2 kilometer. It is equal to 2000 meter. And R1 is 1 by 2, which is zero point 0.5. And R2 is single core has a diameter of 1 centimeter and insulation thickness of zero point 0.4. So R2 will be R1 plus thickness. It will be zero point 0.5 plus zero point 0.4. It will come out to be zero point 0.9 centimeter. And the specific resistance, specific resistance is rho is equal to 5 into 10 raised to the power 12 ohm meter. Okay, so R, the insulation resistance, equal to rho 2 pi L log R2 by R R1. ठीक है, this is R1 and this is R2. This is the zero point 0.4, so this is zero point 0.5, so it will come out to be zero point 0.9. So rho is 5 into 10 raised to the power 12 divided by 2 pi into 2000 log R2 is zero point 0.9 divided by zero point 0.5. If we solve it, the insulation resistance will come out to be 0.234 into 10 raised to the power 9. It will be equal to 234 mega ohm. Okay, so basically the correct answer will be A, 234 mega. I hope you have understood this. If you have any problem in this question, you can ask me right now. So the next question, question number 60. The maximum and the minimum stresses in a dielectric cable are 40 and 10 kV RMS. The conductor dia is 2 centimeter fine insulation thickness. Option A 1.5 centimeter, B 6 centimeter, C 3 centimeter, D 4.5 centimeter. Give me the answer. So write the answer in the chat box. C. Okay, let me see what you have done. Anyone else? Then okay. So let me solve it. A. Okay. We know that G max by G min. What it is equal to? Capital D by small d. Okay. We have to go. What is capital D? It is the intersheath diameter. Okay. Small d is the core diameter. So G max by G min, it is equal to 40 by 10 capital D by 2. So we get here what D, which is the intersheath diameter, and it comes out to be 4 into 2, 8 centimeter. Okay. So basically, let's say this is R and this is capital R. Capital R is the intersheath radius, small r is the core diameter. So we have to calculate this thickness. It will be calculated by capital R minus small r. So thickness equal to intersheath radius minus core radius. Capital R minus small r. So it will become out to be, what is capital R? It is 4 minus small r is 1. It come out to be 3 centimeter. So the correct answer is the 3 centimeter. Okay, I think we should finish it over here. I hope you have enjoyed the session and you have get to know the things very clearly. And if you have any questions, you can ask me right now, or we will continue. We should meet again on the next Sunday with a new topic. Thank you for your joining. If you have don't have any question, you can leave the call.